Okay, so again, if you want to put the tests aside and finish them up after class or when we can set up some time for you, we're going to start on some new material. First, there is a quiz out there on my math lab that is dated for today. Just like last time for test 2, the quiz that's due on test day is an optional quiz. The way I work that is if you do take that quiz and do well on it, it does count as extra credit. What I usually do is take your next lowest, your lowest quiz grade, and I'll bump it with that grade for you. So it's always worth a shot. Okay, so today we're going to start talking about measurement. And measurement is one of those topics that we've all used, but in many cases never really understood. Measurement is about communication. Because let's face it, if you don't need to communicate, not a whole lot of need for measurement. You can always just take stuff and hold it next to each other and mark it off. So where measurement came from is, let's say you and I are trying to build an identical object. If we're in the same room with each other, we just need to walk over, set them side by side and mark it off, and that's good. Everything's identical. But if you're down the hall or across town, there's a difference in need there. We can't just come next to each other. So let's say that you're across town or you're a few blocks away, and I need to express to you how big something is. Let's talk about, let's see what all I have here. Let's talk about my pen here. Say I want to express to you how big my pen is. Or let's do this. Sheet of paper is pretty standard. I'm going to use my pen to measure it. I'm just going to look at it and say, okay, there's 1, 2, it's about 2.5 pens long. So I send somebody down to tell you, okay, the piece of paper is 2.5 pens long. I'm making two big assumptions there. One, I'm making the assumption that you have a pen, and 2, that your pen is the same size as mine. If your pen is equivalent to the red one, you can see the problem there. The red one's way bigger. So you go to measure out that piece of paper, and you go 1, 2, 2.5. You're getting something way larger than what I had. So now you're probably thinking, well, we don't use stuff like that. We've got inches and all that. We've got measuring devices for that. But back then, they didn't. The first start of this need, they didn't have it. They had to come up with their own at some point. So they decided to use was something that pretty much everybody had, and it was pretty close to the same size from one person to the next. If we're looking at standard units, we're going to talk about length first, as you can tell. Going to measure the length of something in standard units, what they started to use, parts of the body. The inch is the length from the end of your thumb to the point of that first knuckle. That's an inch. So if you're going to measure it, you just lay it out here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should be 11.5, but my thumb's a little bit large. They might be thinking, well, people have different sized thumbs. Yeah, they do, but you also got to remember that back when measurement first developed like this, and we're talking thousands of years ago, people were a lot smaller than they are now, and the variation in size was a lot less variation. So it was pretty close to standard. Just to state, it was always a man's thumb because there was a big difference in size between male and female, but obviously that's not necessary now with our standardized measuring devices. So anyway, pretty much everybody had at least one thumb, hopefully, so they could measure. So the inch was the smallest standard unit used. Can anybody tell me what the next biggest unit used? The next biggest standard unit is? The foot. How many inches are in 1 foot? There's 12 inches. Good. Now the foot is exactly what it sounds. From the back of the heel to the front of the big toe is a foot. I'm not going to hold that up to the camera for you. There were some problems with if I wanted to measure the length of this room using my thumb would take a long time to measure that out in inches. So they needed a bigger unit. They used the foot. So you'd put your foot end to end and you'd measure the length of the wall. But the foot was only effective for certain things. If I wanted to measure the height of this wall, for example, I could get up to about here, and going above that height would require me to do some major stretching and probably just have to amputate my foot at the ankle in order to get it all the way to the top. It's not going to work. The foot was only good for measuring things along the ground because that's where your feet are. Not great for measuring things that go up. So they had other units that they used. Anybody know what the unit was that was used for measuring vertical height? The hand. If you deal with livestock, horses, sheep, cows, hands are still used for measuring their height. The hand was the width across the hand at the base of the fingers right here, which is about 4 inches. Now when I say about, now these are exact. A hand is considered to be 4 inches and a foot is considered to be 12. That was not the case originally. Everybody's thumb was different. Everybody's foot was different. But things that were measured in feet were just measured in feet. They weren't converted into inches. At one point, King Henry, and this is in the 500s, he declared that his thumb and his foot and his hand and everything else were going to be the official measurement units of the land. And that's where the first standardized measurement came from. Now, his foot did not contain 12 of his inches either. His hand was not 4 of his inches, but they were relatively close. It was a couple hundred years later, people decided that, well, if you measure something in feet and I accidentally measure the same thing in inches, it'd be nice to be able to compare to see how close to the same they are, or if they are the same, if we're measuring different objects. So that's when they adjusted the feet and the inches to have 12 inches in a foot, 4 inches in a hand, and all the other conversions that we have. They came very late in the game. Again, it was that you measured something in feet, I measured something else in inches, and I want to compare them. Well, there was no comparison up until that point. That was a couple hundred years after King Edward was dead, because if they'd have done it while he was alive, he would have probably had him beheaded. So anyway, King Edward's contribution of declaring his hand and foot and everything to be the official measurement units, egotistic as it was a huge progress in measurement. It allowed us to start getting measuring devices. For example, they came in and they would cut a block of wood or whatever they had, they'd hold it up to King Edward's thumb and they'd mark it off and go cut it and cut a bunch of them and pass them out for everybody to use. Same with his foot and his hand and everything else. And actually having that measuring device is where our modern measurement came from. So now when I go to measure something, let's say I need to measure this stick here. Well, all I'm going to do is I'm going to take that block of wood and I'm going to set it here and just move it over and over and count it up. Now the problem with that was every time I move that little block, that little inch block or whatever I'm measuring with, every time I move there's an error introduced because I'm not going to start it at exactly the same spot the other one ended. As I move it, I lose track of that spot. So they started with taking 2 of them and just flip-flopping them. Flip this one to here, this one goes to there, so that you get a little bit more accurate. And eventually they came up with the idea that's similar to what we use now of, well, let's just take a stick and mark them. And that developed into our modern ruler. And we'll talk more about a ruler later on as we go. For right now, just know that King Edward, even though it was a very egotistical move, was what really enabled all the advances in measurement that we have today. So anyway, we talked about the hand. That's kind of an extinct unit. We're not going to write it down because we don't use it that much anymore. Bigger than a foot, of course, we're used to. What's the next largest unit that we are used to using? A yard. Now that it's been standardized, how many feet are in a yard? There's 3 feet in a yard. A lot of people think of a yard as being the length of a person's stride when they walk, and that is approximately a yard, depending on your height and how long your legs are. but that's not where it came from. The yard originally came, it was a tailor's unit. It was the distance from either the center of your chest or the point of your nose to the end of your outstretched arm. If you ever seen a tailor measure fabric, or even in a fabric store, they'll actually grab out 1, 2, they're measuring out yards. Now they have the specialized tables where they double check it too once they've got it done, but that is how that was measured out. And of course, King Edward declared his yard was going to be the official one of the land. Smaller, we said use the hands for measuring height. Well, hands were kind of small for bigger things. So smaller than a yard, there's an extinct unit that some of you may have heard of called the cubit. Anybody know what a cubit is? Cubit is from the point of your longest finger to the point of your elbow. The cubit, now that these days as people have gotten taller, it's a little bit more than that, but back then with smaller stature people, cubit was about 16 inches. Now, if any of you are familiar with construction, there are a lot of things in construction that are set at 16 inches. Stud spacings in walls, joist spacings in floors, rafter spacings in conventional roofs. Trusses now go at 2 feet instead of 16 inches. So that was the carpenter's unit, just laying out your arm, marking out the distance between objects, just laying your arm down, put your elbow on one where your fingers are where the next one goes. And so again, there was variation there until it was standardized by King Edward of carpenter with long arm and put a lot of extra studs in there. Or short arms had a lot of extra studs. Long arms are a little bit more further spaced. Other extinct units might be a fathom. A fathom was a unit of depth of water. Thought to be the shallowest depth of water that most major vessels could navigate through. It was considered to be the height of your tallest sailor. So a fathom is approximately 6 feet. They would literally throw a sailor overboard and have him stand in the water to see if his head popped out. The top of his head popped out, and it meant it was probably too shallow to navigate. Yeah. Not necessarily terribly humane back then. There are other units like furlongs and stuff like that. Furlong is used for horse racing, is about all it's used for anymore. It was for traveling because a mile was actually considered quite a distance to travel back then because of technology. We're not going to get into those at all. But there is a unit that you might not be terribly familiar with that we are going to talk about, and that is a rod. A rod is about 16.5 or 16.5 feet, or 5.5 or 5.5 yards. A rod was originally a shepherd's tool. The shepherd has two tools, the rod and the staff. The staff was literally your little Bo Peep style hook that you see in the pictures. Most shepherds have that. The rod itself is a sapling tree. They'd find a sapling tree, they would cut it off and debranch it. It was just a big stick. And that was their defensive weapon. If wild animals like a wolf or whatever were threatening the sheep, they would literally scare them away with the stick, fight them away with the stick. Now you think about that 16.5 feet, most ceilings are 8 feet, so it's about twice as tall as a ceiling. That seems like a big stick, but if I'm fighting off a wolf with nothing but a stick, I do want a little distance between me and him. I'll be honest, I'm probably hiding behind one of the sheep saying, here, take the little one. The way that the rod became a measurement unit was, let's say that you had some sheep and I had some sheep and they go down in the valley to graze for the day. At the end of the day, we go to take our sheep back. I say I have 12 sheep, you say you have 16 sheep, and there's 19 sheep in the valley. Well, one or probably both of us is lying about how many sheep we had. And there were a lot of arguments. And even if we agreed on how many sheep, well, I want the nice big fat plump ones and you can take the skinny mangy looking ones, right? So there were a lot of arguments. With cattle and even with horses, they settled this by branding them. They put that permanent mark on them to scar them so they could identify who was the owner. Didn't work so well with sheep for a couple of reasons. One is the wool of sheep gets very thick and you couldn't see the brand after the wool got so thick. Two, not insignificant, is wool is just slightly flammable. Poof. Yeah. So branding wasn't good.
said that.
Yeah. Well, think about that. You put a hot brand on wool, it's
Yeah,
not.
but I guess never really thought of it.
Sure. And ear tags and other marking technology had been developed, but not readily available. They were pricey, clumsy, and to get them to where you were at was tough to do. And in certain areas they had them. So the best bet was to find a landmark. Let's say we found a big rock somewhere, and we're going to say, okay, I'm going to pasture my sheep over here. You're going to pasture your sheep over here. We're going to keep them separate. We're going to do something. Maybe we're going to take all the rocks and stack them up to keep them from crossing over the lines or whatever. That was actually the original fences, by the way. It was just stacking up a bunch of rocks into a pile so the animals didn't want to cross it. But that was the beginning of land division, land ownership. If you're going to keep yours over there, I'm going to keep mine over here. And so there weren't arguments over, well, you got bigger land than I do. I would take my rod, my big stick, I'd put it on the ground here, and then you'd set yours down, and we'd count 1, 2, 3, and okay, I've got 30 by 100, and you've got 30 by 100. We have the same size pasture or whatever. To this day, if you look at the official description of a piece of land, land is measured out in rods. The legal description will be from this landmark, which is usually a permanent surveyor's stake now in the ground. It is 120 rods to the west and 480 rods to the north. So anyway, bigger than a rod. Like we said, we had the furlong and other things, but we're going to jump up to the mile. Anybody remember how many feet are in a mile? There's 5,280 feet. Or you could look at it in yards as 1,760 yards. There are a lot of rumors as to where the mile came from. The best description or the best theory that I have found comes from the Greek and Roman military. The Roman word milli stands for 1,000. In fact, if you look at property taxes, you see a mill rate. The mill rate is your dollars per thousand of value. In most townships, the mill rate is between 20 and 24. That's saying for every $1,000 of value, you are going to pay $24 in taxes. So a mile, if you looked at a Roman soldier, that was the distance that they would march in formation at 1,000 paces. Now, a pace was defined as starting on your left foot, going to your right foot, and back to your left foot. So you think about that, one pace, starting on your left foot to your right and back to your left, it's about 5.28 feet. So 1,000 would be about 5,280 feet. Okay, so that's where all those units came from. Let's take a look at converting a little bit. Now, most of you know how to convert length, at least from the basic units. If I gave you 3 feet and asked you how many inches is that, most of you could just yell out how many. What's that? Careful. Somebody there said it in Superior. 36. We've done this often enough that we know 12 inches in a foot. We're just going to go 3 times 12 to get 36, right? But if we haven't done that and we're not familiar with it, how can we approach that? Well, just like when we did our fractions, if I had 3/4 and I want to change it into something else, I could multiply the top and bottom by the same thing. Let's say I could multiply by 5 over 5. 5 over 5 is equal to 1, right? So if I multiply by it, I'm not going to change the value. I'm only going to change the appearance. So 3 times 5 is 15. 4 times 5 is 20. 15/20 looks different than 3/4, but it has the exact same value. With my measurement, I'm going to do something very similar. I'm going to multiply by a fraction that has a value of 1. The term we use for that is called a unity fraction. And what's in my numerator is going to be equivalent to what's in my denominator. What units do I have right here? Feet. So I want feet down here. 1 foot is equal to 12 inches. Now you might be looking at that saying, that's not equal to 1, it's 12 over 1. But 12 inches in 1 foot are the exact same value. So when I'm multiplying by that 12 inches over 1 foot, I really am multiplying by 1. The reason I'm going to multiply by that is now the feet here will cross cancel. That's why I put feet on bottom, so it would cancel out the feet on top of the other fraction. And 3 times 12 inches is 36 inches. 1 times 1 is 1. Now with feet and inches, it might not be necessary to use this conversion factor, this unity fraction. But let's say I ask you to convert 99 feet into rods. Well, most of us don't know this one off the top of our heads. So let's set it up. 99 feet over 1. In my other fraction here, usually it's easier for me to figure out what unit has to go on bottom. What unit has to go on bottom down here? Feet, because I've got to cancel out the feet. Now to figure out what has to go up here then, what am I changing it into? Rods, right? That has to be rods. Now I can look up my relationship between feet and rods. What is that relationship between feet and rods? If I look up here, 1 rod is 16.5 feet, isn't it? 1 rod, 16.5 feet. So my feet will cancel out. 99 times 1 rod is 99 rods. 1 times 16.5 is 16.5. And then I divide it out. 99 divided by 16.5 should give me 6. And there it is. So there's 6 rods. Now in your textbook and on my math lab, the examples I gave you here came out exact. But they might not always. They might come out to be a decimal. In your textbook, when we do conversions, and it's going to be more so when we do the metric to standard conversions or standard to metric, they always want the number that goes down here to be 1. So this would be 1 foot, and then whatever goes up here would be a decimal number of rods that's 1 foot. So it'd be like 0.601 or something like that is what it comes out to be. And we'll talk about that more when we look at our metric to standard conversions here in just a little bit. So let's look at some of our other units. That's length. Let's talk about weight. We're going to go a different direction with weight. We're going to start out with the larger units and work our way down to the smaller ones. For weight, what is the largest unit that most of us are familiar with? The ton. You got it. 1 ton. What's our next smallest unit? It's a big jump. Pound. Very good. How many pounds are in a ton? Most people would say 2,000, and that is a correct answer. 2,000. Now, in this class, anytime you see a ton, it is 2,000 pounds. 99.9% of the time in the world you see the word ton, they're talking about, well, in the United States, I should say, in the world is different. When you see the word ton, it means 2,000 pounds. Technically, this is what's called a net or a short ton. But again, that's almost always what is used. Of course, if there is a net or a short ton, that implies that there is something called a gross or a long ton. You don't need to write this down because it will never come up in the class, but I just want to expose you to it so you know what's out there. A gross ton is 2,240 pounds. This came from, again, the origins of measurement. Tons were originally used for buying and selling grain, and you used a scale. Well, you couldn't put a ton of grain on a scale, it would just fall off. So you had to have a container to hold it. You think of like your paycheck. Your gross pay, if you work 30 hours in a week and get paid $10 an hour, 30 times 10 is $300. That's your gross pay. You actually get $300? No, they take out taxes and other things, and you'll get maybe 240 or less. That would be your net pay. So the same here. The gross was the grain along with the container. The net was the actual amount of grain you got. The container that held a ton of grain was about 240 pounds. So again, in the world today, in the United States at least, if you hear the word ton, it's almost never a gross ton. It's usually a short or a net ton. But be aware that there may be a different one out there. Now there's also something called just a gross as well. It's different than a gross ton. A gross is a dozen. Okay, so smaller than the ton. We talked about the pounds. The abbreviation for pound is LB. Now it would make sense to use PD for pounds, wouldn't it? But back in the bookkeeping for buying and selling grain at that time, PD was already used as the abbreviation for paid. So they didn't want to use that. LB stands for libra, which is the Latin word for pound. By the way, one of the unique things about the English language, especially Americanized English, is if enough people screw something up often enough over a long period of time, it becomes acceptable. PD is now an acceptable alternative abbreviation for pound. Kind of like the word potato. Some of you are old enough to remember back in the 80s. PDS, yeah. Some of you might be old enough to remember back in the 80s the big fuss about the vice president misspelling the word potato at the National Spelling Bee. He actually spelled it correctly. The correct spelling for potato is P-O-T-A-T-O-E. But over time, so many people had left the E off when they spelled it, that became an acceptable alternative spelling. That actually only came into effect in the 70s. You had a vice president who went to college in the early 60s, late 50s. For him, OE was the correct spelling. And when the person left the E off the end, he said, "You were wrong." And, well, he was technically correct. But they made a big fuss about it. So anyway, I know I got off topic. Just so you know, PD is now an acceptable alternative. Smaller than a pound, we use ounces. How many ounces are in a pound? Not everybody at once. 16, there we go. Just like pounds, I don't know why they didn't use the English word, but they used the Latin word, which I don't remember offhand right now. Used OZ is from the Latin word for ounce, is the abbreviation for ounce. Smaller than an ounce, we have a dram. A dram sounds like a metric unit. It is not. It is an English unit. And there are 16 drams in an ounce. A dram was actually one of your original apothecary units for medications. They might prescribe an eighth of a dram or a quarter of a dram of medication to you. There was also something called minims. Minims were very small unit. And then there was grains. 1 pound contains 7,000 grains. Grains have now been absorbed into the metric system because they were so entrenched in medicine. When things switched over to the metric system, they ended up having to take the grains into the metric system and absorbing it into it. But originally, grains was 7,000 grains in 1 pound. They use this for gunpowders, they use it for medications and other things. And of course, the conversions are going to be the same as what we used up above for length. You use the conversion factor, you put the unit you're canceling out on bottom, unit you're going to on top. Now, something to mention, even though I know we're running a little short on time, I think it's important. You hear on the news all the time, gold has reached $2,000 an ounce or whatever. When they're talking about precious metals, they are not talking about these pounds and these ounces. One of the problems with the standard system Actually, it used to be called the English standard system up until the 1980s, when England switched over to the metric system, which means the United States is now officially the only industrialized country in the world that's not totally on the metric system. But that's a different discussion. I've said that King Edward declared that his thumb and his foot were going to be the official measurements of the land. Unfortunately, in different countries, there were different rulers that declared their thumbs and whatever to be the official units. And so that was one of the problems with the standard measuring system. It was not standard. Within a country it was standard, but if you traded from one country to the next, my country's yard and your country's yard might be very different. Or my country's pound and your country's pound might be different. So what caught on for certain things, there were trading centers. For precious metals, the trading center was actually the Greek island of Troy in the Mediterranean Sea. That seemed to be where precious metals got bought and sold the most. So precious metals are bought and sold with troy measurements. One troy pound is approximately 0.83 or 0.82 regular pounds. So a troy pound is actually smaller than a regular pound. However, one troy pound contains only 12 troy ounces. So a troy ounce is actually bigger than a regular ounce. So when they're talking about an ounce of gold, that actually it's a little bit more than what we would consider to be an ounce. You will never be tested on this, by the way. I just threw it out there for you, just so you're aware. You hear these terms all the time. It's something to be aware of. At some point, some of you might be sucked into investing in precious metals, and it's not a bad investment. Be aware. Okay, others that we're going to talk about capacity. A lot of people mistakenly equate capacity with volume. Volume is not capacity. Volume is actually a conglomeration of lengths. If something is a volume, what we're doing is basically a box. You're taking the length, the width, and the height, measured in length units, inches, feet, whatever, and you're multiplying it together to get a volume. So volume would be cubic inches or cubic feet or whatever length measurement we're using. Capacity is a standard container. Now we're used to using a gallon for capacity. 1 gallon was actually the standard size of a man's hat. That's about what you could hold in a man's hat. Now you hear the phrase a 10-gallon hat. No, a 10-gallon hat does not contain 10 gallons. A 10-gallon hat was just a really big hat, bigger than a standard hat. So that was kind of their sarcastic phrase of, oh, there's a 10-gallon hat there. But a 10-gallon hat was just slightly bigger than like a gallon and a half, really, is all it was. Smaller than a gallon. What's our next smallest unit? Anybody tell me? A quart. Very good. How many quarts are in a gallon? There's 4. The word quart came from the word quarter, meaning a quarter gallon, or 4 of them in a gallon. Smaller than 1 quart. A pint. How many pints in a quart? 2 pints in a quart. Smaller than a pint. Well, there is a jump from pints to ounces, but there's one in between. The cup, which is 2 cups in a pint. Cup is sometimes actually referred to as a half pint. A little warning here. Quart and pint. Quart is abbreviated QT and pint is abbreviated PT. In some type fonts, the Q doesn't have the little curve on it, it just has a straight tail. They're mirror images of each other. If you have any dyslexic tendencies like I do, it's really easy to confuse those two, so be very careful as you're reading. Smaller than a cup, somebody already said this one. Fluid ounce. How many fluid ounces are in a cup? 8. There's 16 fluid ounces in a pint, 8 in a cup. Now here's the one some people are familiar with, but you never know. Smaller than a fluid ounce, we have tablespoon. Anybody know how many tablespoons are in a fluid ounce? 2, right? Probably more people know that there's 16 tablespoons in a cup. So 2 times 8 makes the 16. There's 2 tablespoons in the fluid ounces. Now, the abbreviation for tablespoon, I use a capital T and then BSP. There are actually several of them. There's just capital T SP and just capital T, or there's a small T BSP. All 4 of those are acceptable abbreviations for tablespoon. If you see a capital T, it means tablespoon. But even if it's a little t, if there's a B in there, that's a tablespoon as well. Smaller than a tablespoon, of course, is the teaspoon. The teaspoon never has a capital T on it. Anybody remember how many teaspoons are in a tablespoon? 3, very good. Teaspoon would either be small TSP or just a small t. So it's very confusing with those abbreviations, and trust me, it makes a difference if you're making chocolate chip cookies and it calls for 3 teaspoons of salt, and you put in 3 tablespoons. Not good. I haven't turned down too many cookies in my life, no matter how bad they are, and I could not get those down. Now, you're not going to need these next few. I'm just going to put them up there because, well, curiosity. Most people don't realize they're real units. Smaller than a teaspoon. There are 2 teaspoons in 1 dash. 1 dash contains 3 pinches. And 1 pinch, I can never remember how to spell this one right, contains 2. I think this is right, smidgens. A dash, kind of like a salt shaker, you dash the salt shaker. Well, they had larger spice shakers back then. So you just 1 quick flip and shake of the spice shaker was a dash. A pinch is just what it sounds like. You reached into whatever it was and you pinched your fingers and threw it in. A smidgen, this one's kind of a little disgusting to me. You stuck your finger in whatever stuck to your finger. So the cook with sweaty hands had kind of big smidgens. A cup, by the way, is just your cupped hand, you know, whatever you're holding your cupped hand. I've actually tried it, and if you're careful, it actually is pretty close to accurate. So anyway, those are our units of capacity. Time to go on to the metric system. A lot of people do not understand how old the metric system is. A lot of people think because we just started hearing about it a lot in the United States in the 70s and 80s. A lot of people, if you asked them, they would say, oh, maybe 1950s or 60s at the earliest. It was actually, they started developing it in the 1880s and actually fully developed it in the 1890s. Now, we are not, most people resist the metric system, but there's a lot of advantages to it. I mean, as we talked about, I know I spent a lot of time talking about the development of the standard system, but the standard system evolved. It started out with a need to communicate, as I said, but the units were never meant to be used together. They were forced to go together so that they could convert from one unit to another. But this caused a lot of issues. And so the metric system was developed to solve a lot of those issues. They'd been using the standard systems for literally thousands of years, and they knew what the problems were, so they developed the metric system to address those problems. So I'm just going to put created for the metric system, actually intelligently created. I mean, it's one of those, once you get used to it, it actually is very easy, very much simpler than the standard system to use. It's just your familiarity with the standard system a lot of times will hold you back from embracing the metric system. One of the things I'm going to go back here and bring up, like a gallon. If I wanted to convert, we said, the difference between capacity and volumes. 1 gallon is approximately, not even exactly, 231 fluid ounces. Or sorry, 230 fluid ounces. Never mind. Sorry. That's not what I was looking for. 231 cubic inches is a gallon. Sorry. My mind was wandering for a second. Cubic feet to a gallon. If you think about it, cubic foot. They have a 5-gallon bucket. Most of you can picture that. Is a 5-gallon bucket more or less than a cubic foot? What would you guess? Is a 5-gallon bucket, is that more or less than a cubic foot? Less? Most people say more because it's tall, but it actually is considerably less than a cubic foot. 1 cubic foot contains, depending on what book you're looking at, 7.48 or 7.5 gallons. 7.48 is a little more, it's where you round it off. So it's only, a 5-gallon bucket is only about 2/3 of a cubic foot. Again, those are very, very sloppy, and that's approximate either way. It's not exact. Very sloppy conversions from length to capacity. So the metric system not only addressed these odd conversions, like here's a 2, a 4, a 3, and a 16, and an 8, or for length, you know, having a 3, a 12, a 5,280. The metric system addressed those awkward conversions within units, then also addressed the conversions from one unit to another. So in the metric system, there was only 1 unit for each thing. For length, the only unit used was the meter. Now the meter, compared to our yard, is like 39.4 inches long. You might be thinking, well, wouldn't it have been nice if the meter was created to be equal to a yard? And yeah, that would have made life a lot easier on us. Well, it is. Unfortunately, as I mentioned, the yard was not standard from country to country. The metric system was developed in Switzerland, and the meter is actually equal to the Swiss yard. Fortunately, not equal to the US or English yard. The only unit for capacity is the liter. I'll explain why I capitalized that in just a second. And the only unit for mass is the gram. The abbreviation for meter is just M, little m. For liter, I was always taught capital L, because back when I was learning the metric system in the 80s, most of your typewriters, the small L and the number 1 were identical. So if you had, you know, this written, is that 91 or is it 9 liters? Well, if you use the capital L, it's very clear that is 9 liters. Now on most of your computer fonts, the L and the 1 are distinguishable, so it is okay to use a small L. I still use the capital L because obviously my writing is not that clear, and it's just what I'm used to. And then for gram, for mass, it was a small g. So if I had to measure anything significantly smaller or larger than those, they had prefixes that defined a fraction of those. Like deci meant 1/10. So a tenth of a meter is a decimeter, abbreviated dm. A tenth of a liter is a deciliter. A decigram is a tenth of a gram. Smaller yet was centi. Centi was 1/100th. Abbreviated with a small c, so a centimeter was 100th of a meter. Centiliter was 100th of a liter. Centigram was 100th of a gram. Next was milli, which meant, you know, mil meant 1,000. Milli meant 1/1000th. So a millimeter was mm, milliliter, ml, milligram, mg. Now you can see here, these went by every 10, you know, 10, 100, 1,000. After that, they didn't go by, you know, they didn't do 10,000, 100,000. They skipped to 1 millionth. I wrote that kind of sloppy. 1 millionth was micro. Now the m, little m is already used for milli, so for micro they use the Greek letter mu is the Greek m. So that is the abbreviation, you know, so mu m would be a micrometer, mu L is a microliter, mu G is a microgram. Now, where the micro is used the most is in the medical fields. And the medical field was one of the first fields to put all of their information into a computer electronically. There is no mu key on the keyboard. So what they used is MC. So MCM was a micrometer. MCG was a microgram. MCL was a microliter. Going the other way, deca meant 10. Now D was already used for deci, so for deca they used DA. So DAM was a decameter. DAL was a decaliter. DAG was a decagram. So 10 grams, 10 meters, 10 liters. Hecto meant 100. So HM was 100 meters. HL was 100 liters. HG was 100 grams. And kilo was 1,000. So KM was a kilometer, KL was a kiloliter, and KG was a kilogram. And then again, just like on the other end, they didn't go every 10 anymore. They went 10, 100,000, but then they skipped the 10,000 and 100,000 and went up to a million, which was mega. You notice I put a capital M on mega because little m was used for milli, and then mu was used for micro, so for mega they used capital M. Capital M, little m was a megameter. Capital M, and then either a capital or small l was a megaliter. Capital MG is a megagram. In use, when they developed this, they thought these were all going to be useful, but in use, there was too many of them. So in practical use, they tend to use the main unit, and they tend to use kilo, the thousands. Hecto and deci don't get used very much, or hecto and deca don't get used very much. Mega, only in special, a megameter is 1,000 kilometers. Well, the distance around the Earth at the equator is 25,000 kilometers, so it would be 25 megameters around the whole Earth. It was too big to be useful. A megaliter, same thing. A megaliter is about 250 gallons. It's just way bigger than it's needed. Megagram is used a little bit, but it has actually been renamed as a metric ton. So a megagram is 1,000 kilograms, or 1,000,000 grams is a metric ton. Actually relatively close. It's about 22,208 pounds. It's fairly close to a gross ton. On the other end, a milli is the unit that got used most. In the medical field, you see that a lot. In the United States, centi caught on as far as centimeters. Centiliters and centigrams didn't really catch on. The centimeter caught on because we were so entrenched in our inches. The centimeter is the closest unit to an inch. That doesn't mean the rest of these aren't used. Like a deciliter is used in the medical field for blood testing. If you do your cholesterol and then you come out as a 180, that's 180 milligrams of cholesterol per deciliter of blood. Okay, that's all the time we have for today, so I'm going to end it there. On Monday, we'll start off with our metric to standard conversions. Those do appear just a little bit in your homework. So something I'm going to mention on that right now quick is, let's say you look in your book, and I don't remember what page it's on, but you might have 1 inch is equal to 2.54 centimeters. This is chapter 10, I believe. But there might be a look in there, well, there's another one given that 1 centimeter is equal to 0.39 inches. That's approximate. They might go out to a couple more digits than that. How do I know which one of those to use to convert? I mentioned this earlier. If I am going from 5 inches into centimeters, well, I put my 5 inches over 1, and when I go to do my conversion factor, of course, inches are going to go on bottom here, right? And centimeters on top. I'm going to pause. Does everybody see why inches are on bottom and centimeters are on top? Yep. So the inches will cross cancel. Well, I had mentioned the book in my math lab try to encourage you to always put 1 in the denominator. So that means you have to use this one, because it's 1 inch equals 2.54 centimeters. And then you would go with that. That ends up being what? 12.62 or something like that, or 12.7. It doesn't matter. You guys can do the multiplication. But they put 1 on the bottom so you don't have to divide out later. If we were going from, let's say we were going from 15 centimeters into inches, now we're starting out 15 centimeters, putting it over 1 to make it a fraction. Now the centimeters have to go on bottom so they cancel out, and inches on top. Well, we want 1 in the denominator, so we'd use this one. 1 centimeter is 0.39 inches, and then go from there. When you're doing my math lab, they come out very, very, very close to the same. Unfortunately, sometimes they're off by a couple hundredths or a couple thousandths because the round off and the conversion factors. So if you're doing my math lab and you did this one, if you did 15 centimeters over 1 and then put 1 inch is 2.54 centimeters, technically that works. It's still correct, but the round off error is going to be far enough off that sometimes my math lab will count it as wrong. So if you get one wrong in my math lab and you go back, in my math lab, it'll show up like this with the red corner here. When you're looking back at your answers, that red corner is indicating that it was wrong. What shows up in the window here is the correct answer. To see what you answered, you got to hold the mouse, the pointer over the top of that, and it'll say you answered whatever. If your answer and the correct answer are within a couple hundredths of each other, or a couple thousandths, that's probably because you did this, which isn't a big deal. If it does that on the homework, don't worry about it. It doesn't matter. Your homework's graded for effort. If it does that to you on a quiz, let me know and I will go back in and look at it and I'll change that grade for you. Okay, so remember there is an optional quiz, extra credit quiz that you could do today. You already did it? Cool. And then there is a new homework that is not optional, that is required, that is due for Monday. If you need more time to work on the test, feel free to take as much time as you need here today. I think the buildings are all open until at least 4:30. Hopefully you don't need that much time. Otherwise, if you have to get going and you need to come back and finish later, talk to someone at your location there so you can leave it with them and come back and finish it up later.